This cube here is a mole of copper, which has 602 billion trillion copper atoms. And we can easily look up the mass in grams for 1 mole of copper atoms from the periodic table. Depending on your textbook and your professor, the mass for 1 mole of a substance goes by many names. To simplify things, we will consistently refer to as molar mass. And to find the molar mass of an elemental substance or a compound substance, we will need the chemical formula for that substance and the periodic table. Here is the periodic table. For the element copper, Cu stands for 1 copper atom in a chemical formula. And this number, with decimal places, stands for the mass in grams for 1 mole of copper atoms. So the mass in grams for 1 mole of copper, or 602 billion trillion copper atoms, is 63.55. In other words, the molar mass of copper is 63.55 grams per mole. We could also write this as a ratio, 63.55 grams of copper per 1 mole of copper, or 1 mole of copper per 63.55 grams of copper. And when converting between grams to moles or moles to grams for the element copper, these ratios are useful as conversion factors. Note, some versions of the periodic table may give you many decimal places for the mass of 1 mole of a substance. Like this one here, you can see it uses 3 decimal places for copper. Check with your professor for guidelines on decimal places and rounding. These numbers are measured values with significant figures for mass. For the purposes of our examples, calculate molar masses with 2 decimal places, which will be sufficient for our needs. And we can always use more than 2 decimal places when needed. This cube here is a mole of aluminum. Which of the following should you use as a mass in grams for 1 mole of aluminum atoms? The air that we breathe in is a mixture of different gases, and it happens to contain the diatomic elemental substance oxygen, written as O2. Since each molecule of oxygen contains 2 oxygen atoms, a mole of O2 would contain 2 moles of oxygen atoms. And from the periodic table, we see that the mass in grams for 1 mole of oxygen atoms is 16. So, the molar mass of O2, which contains 2 oxygen atoms, will be twice this amount. In other words, the molar mass of O2 is 32 grams per mole. Again, we can write this as a ratio, 32 grams of O2 per 1 mole of O2, or 1 mole of O2 per 32 grams of O2. And when converting between grams to moles or moles to grams for the elemental substance O2, these ratios are useful as conversion factors. To recap, the mass in grams given on the periodic table is for 1 mole of atoms for an elemental substance like copper or aluminum. And for the molar mass of elemental substances like O2, we would account for the fact that it has more than 1 mole of atoms by multiplying the mass given from the periodic table by the number of atoms it contains as indicated by the chemical formula. So far, we have looked at the molar mass of elemental substances, but how will we find the molar mass of compound substances that contain more than 1 element? For example, table salt, written as NaCl, contains 2 different elements, Na, which is sodium, and Cl, which is chlorine. How will we find the molar mass in grams for 1 mole of this compound substance? Looking up the periodic table, we see that the mass in grams for 1 mole of sodium atoms is 22.99, and the mass in grams for 1 mole of chlorine atoms is 35.45. Since 1 mole of NaCl contains 1 mole of Na and 1 mole of Cl, the molar mass of NaCl will be the sum of the mass for 1 mole of each element making up this compound substance, which is 58.44 grams per mole. Here's a mole of water, or H2O. Notice it contains 2 elements, hydrogen and oxygen. So to find the molar mass of H2O, first we will need to find the mass in grams for 1 mole of each element making up this compound. The mass in grams for 1 mole of hydrogen atoms is 1.01, but the chemical formula indicates there are 2 hydrogen atoms, so we will multiply the mass of 1 mole of hydrogen atoms by 2. And the mass in grams for 1 mole of oxygen atoms is 16. Thus, the molar mass of H2O will be 2.02 plus 16, which is 18.02 grams per mole. Use the periodic table to find the molar mass of CO2. As a bonus challenge, let's take a look at aluminum sulfate. The chemical formula for aluminum sulfate tells us that 1 mole of this compound contains 2 moles of aluminum ions and 3 moles of sulfate ions. Notice that the chemical formula also tells us that each sulfate ion contains 1 sulfur atom and 4 oxygen atoms. Therefore, 1 mole of aluminum sulfate would have 2 moles of aluminum atoms, 3 moles of sulfur atoms, and 12 moles of oxygen atoms. So to find the molar mass of aluminum sulfate, we add the mass of 2 moles of aluminum atoms, the mass of 3 moles of sulfur atoms, and the mass of 12 moles of oxygen atoms, which is 342.17 grams per mole. This compound is magnesium nitrate, which has 1 magnesium ion and 2 nitrate ions. What is the molar mass of magnesium nitrate?